Okay, so now let us do this next chapter, which is system of particles and rotational motion. So in the previous set of chapters, whatever we did in the previous chapters, we obeyed, we followed the Newton's laws of motion and all the things we calculated work, energy, and power. So all those things we calculated assuming that our mass is point mass, right? So we always considered that all the bodies, all the objects were of point mass. But in our daily life, we see all the objects, they have, so they are not point masses, right? They have different kinds of distribution of masses, right? So let's say we are humans, right? And yeah, so let's say this is my drawing is bad. So yeah, this is V. Sorry about my drawing. So this is
Yes.
V, and we see that we are not point mass. We have so all the mass we are made up of all the different masses, right? Constituent mass. But up until now, we were talking about all the laws of motion with the point mass, right? But now in our daily life, we see that all the objects have different kinds of distribution. So those are called system of particles, right? All the individual particles made up some system. So mainly there are two kinds of system of particles, right? So two kinds of system of particles, which means that we have ensemble of different kinds of particles, right? And they are all together making a system. So two kinds of system of particles. One is this discrete system, and the other one is this continuous system, right? So what is a discrete system? In which the particles are finite, right? Individual particles which are making that system. So individual particles are finite. You can count them, right? And in the continuous system, the individual particles are infinite. Right? And you cannot count them, but you can calculate the total number of particles, right? So in this way, there are two kinds of distribution. So let's say we have this object, right? So there are these four masses, right? So we can count that there is this mass m1, this is mass m2, this is mass m3, this is mass m4, this is mass m5. So we can count all these individual masses, right? And let's say we have this sheet, right? So the sheet will contain all the different kinds of masses, but you cannot count the individual masses, right? So the individual particles are infinite. So these the kinds of distribution that we have, right? And then, so you also have this rigid body with which you define the motion of all these particles, right? So motion of system of particles is described by rigid bodies. right? So what are these rigid bodies? So let's say you have these charger, you have these bottles, all these bodies. Let's say you have some jelly, right? So if you move the jelly, then it will deform, right? So its
Yes.
shape, yeah, its shape and size will deform, right? So
Yes.
those kind of object, we cannot define the motion of those kind of object. Whenever we have some object whose shape and size are fixed, so for those objects we can define the motion, right? So then we defined those kind of bodies as rigid bodies. So the type or the types of body which have a definite shape and size. They have definite shape and size as well as, so the difference or the distance between their con- constituent particles remain the same. This point is very important, right? The distance between their constituent particles remains the same. So let's say you have a rigid body like this, right? And then you have this mass m1, you have this mass m2, right? And then you have this mass m3. So let's say if these bodies are moved, this object, this rigid object is right, then the distance between this point and this point will never change. Distance between this point and this point will never change. Distance between this point and this point. So the distance between two points will never change. So those kind of bodies are called rigid bodies. And why they are important? Because we can define the motion of only those kind of bodies, right? If we have some jelly-like structure, if we have some different structure where, let's say, if I move in this way, then this distance become this one. So then I cannot define the motion of this object, right? Because the position are always changing. So in that way, we require rigid bodies to define the motion of the object, right? So this was about the rigid body. And how many kinds of motion does a rigid body have, right? So kinds of motion of a rigid body. So there are three kinds of motion. One is this translation motion, and then you have this rotational motion, right? And then you have this rolling motion, right? So in the translation motion, the body is moving in, there's no axis of rotation, right? And the body is moving in some direction, right? So the direction is not repeated. But in rotational motion, you have some rotation of axis or axis of rotation, right? And with this axis of rotation, the object is moving, right? And the speed is same. So angular velocity is same. So this the rotational motion contains this axis of rotation. And in the rolling motion, whenever you combine the translation plus rotational motion. So whenever these two motion are mixed, then that kind of motion is called rolling motion. So let's say for translation motion, right? So let's say you have this rigid body and it is moving in this direction. Then this kind of motion is translation motion. And let's say you have a fan. So this is a translation motion. And let's say you have a fan which is hanging with this ceiling, right? So this is the fan and it is so right. You have this fan. So this fan is rotating with this axis of rotation, right? This fan is a rigid body and it is having an axis of rotation. So whenever you have an axis of rotation, right, and this fan is not displacing with this axis of rotation, then this is called the rotational motion, right? So this fan is only having this rotational motion. But let's say you have this rolling motion. So let's say you have an object which is inclined at so you have this inclined plane and you put some object in there. Let's say spherical or cylinder or anything like that. So then you push this object. So this will move in this direction as well as it will have some rotation with its own axis, right? So this spherical ball will have the rolling motion. So it will have this translation motion and it will have this rotation. Okay.
Yes, sir.
Yeah. And in translation motion, so to describe the translation motion, this idea of center of mass is very important. So for the case of translation motion only, you define this center of mass. You don't require the center of mass for this rotation. Okay. Yeah. So we'll talk about the center of mass in a moment, but why this center of mass is important? So we will see that. But you please note down these parts. So what is the masses that are okay, so nobody is here to right. So what we will do is that we'll keep this class again for 1 hour, right?
Yes, sir. So can you scroll down?
Types of so you understood that why these rigid bodies are rigid, right? Because we cannot describe the motion of the non-rigid bodies, right?
Yes, sir.
At least in a simple way, we cannot describe, right?
Yes, sir. Can you scroll down? Done, sir.
Done. Okay, so then let us talk about this translation, right? And in translation motion, we talk about the center of. So why do we need this center of mass, right? So center of mass is the point where all the mass of the rigid body is so the point where all the mass of the rigid body is situated, right? Or concept. And why it is necessary? Let's say we have this square type of a rigid body, right? And it is moving. So what I can do is that I can change this square type of object. Let's say there is this mass m1 here, there is this mass m2 here, there is this mass m3 here, there is this mass m4 here. So this is a discrete system, and this force system is moving in this way, right? So to write the Newton's law for this motion would be difficult. So what I do is that I define this object in a way that where all this center of mass is located. So we have this mass, which is, and this point is the center of mass. And then I can define the Newton's law, right? So I can change this object, change this specification of this object to a point mass, right? Change this specification to point mass, right? And if I can define a point mass, then I can define all the movement of this point mass, because we all know the Newton's law, we all know work, energy, and power, we all know this inertia and all these things. So we can, with the use of this center of mass thing, we can define the movements of all these objects, all these rigid bodies. Is that clear? Why this center of mass is needed?
Yes, sir.
Yeah. So now let us find out that how can we calculate this center. So let's say that we have a line, right? We have this x-axis, and we have put two masses on this x-axis. So this is m1 at x1, right? And we have this m2, right? And this is at x. Okay, so these are the coordinates of m2 and m. And if I want to find the center of this object, right? So the center of mass of this object would be would lie in this point. So the center of mass of this object, which is defined as x here, this would be defined as the mass of m1 into x1 plus mass of m2 into x2 divided by m1 plus. So in this way, I can define the center of mass of this object, right? So let's say this is the x coordinate. Okay, is this part clear?
Yes, sir.
Yeah. So now let's say I have, so this was only in one direction, right? And this contained only 2 point particles. But let's say I have a numerous discrete system, right? So I have a discrete system and I have numerous points. Let's say M3, M4, M5, M6, all these different masses that are there. Then I can calculate all the coordinates of the center of mass. So in general, the center of mass of part of n particle of n particle system this is defined as, so there would be three coordinates, right? The coordinates would be x, y, and z, right? So the x center of mass would be m1 x1 plus m2 x2 plus m3 x3 plus so on up to mn xn divided by m1 plus m2 plus m3 plus m4 plus m3. Okay, so this is the x coordinate. And then we have the y coordinate, which would be m1 y1 plus m2 y2 plus m3 y3 plus mn yn divided by m1 plus m2 plus m. This is a y coordinate, and then the z center of mass would be m1 z1 plus m2 z2 plus mn zn divided by m plus m2 plus m. So we have a system of particles, right? Let's say in three dimension. And then we are defining the x, so then we are defining the x, y, and z coordinate of this object. So there are m1, m2, m3, m4, n number of particles are there. Okay, and we are defining the center of mass of this object. So this would be the center of mass of this object. Okay, and remember what kind of system is this?
Um,
Yeah, so what kind of
when it's rigid,
yes,
rigid body,
this is a rigid body. Of course, we can define only the rigid body, but what kind of particles are these? Continuous or discrete?
discrete.
Discrete, right? Because we can
Yeah.
count M1, M2, M3, Mn, right? So whenever we can count these M's, then we are in the discrete system. And whenever we cannot count the system, then we are in the continuous system, right? Okay,
Yes,
so
sir.
yeah, and okay, we will do some questions about this. So let's say that we have to find the center of mass of a three particle system having masses, let's say m1 or m, 2m, and 3m placed at vertices of equilateral triangle. Okay, so we have a system of particle like this. This is, let's say, 3m. This is m, and this is 2m. Right, the three particles, and they are at the vertices of an equilateral triangle. So what would be the distance? Let's say distance is e. Okay. So to calculate the center of mass of this object, what do I need? Yes. What do I need? Just see these points. So these are what? X1, X2, Y1, Y2. What are these?
Where the center mass of each of the particle.
Yeah. So this center of mass or the center of mass of the whole particle. This x1, x2 are the points where these individual particles are located. So coordinates of these particles, right?
Yes, sir.
So M1 coordinate is x1, y1, and z1, right? M2 coordinate is x2, y2, z2. So all these x1, x2, y2, y1, all these are coordinates of these individual particles, right?
Yes, sir.
So to calculate the center of mass, we need the coordinates of these particles, right? We
Yes,
need
sir.
x1, x2, y1, y2, and all these. And you see that this triangle is in the plane, right? So which axis would not be there?
Z axis.
Z axis, we absolutely right. Good. So Z axis would be not there. So we'll only have X and Y center of mass, right? So let us break this triangle in the coordinates and write all those coordinates. So we have this is the Y axis, and then this is the X axis, right? So let's say this point would be what?
0, comma, 2,
Okay,
comma 0.
0 comma 0, right? This is the origin.
Yes. Yes, sir.
This is 0 comma 0, and we're not talking about the masses, distances. So coordinate of this point would be,
2, comma 0.
what is the distance in x direction?
2 meter.
No, no, this is mass. So this is 2m mass, right?
Uh,
Yeah,
A, A.
yeah. So these are masses. Having masses m, 2m, and 3m. So, yeah.
So
Sorry, this
it'll
is
be
looking
2,
like
comma,
2 meter. Yeah. So a
it's
comma
fine. So
0.
it'll
Yes.
be A, comma 0.
Absolutely correct. Yes. And this one,
A, comma, 0, comma A.
0 comma a. So 0 comma
Um,
a is here.
uh, um,
This point, yeah. How much x distance we have covered? In equilateral triangle, this is the perpendicular, right?
yes, sir.
A by 2, right? In x direction, a by 2. In y direction, how much?
A.
So a by 2 and a. Is this clear?
Yes, sir.
Okay, so now we can calculate the center of mass. We have x1, y1, we have x2, y2, and we have x3, y3. So we have, let us write all these values. So M1 is M, and X1 is 0, Y1 is M2 is 2M, X2 is A, and Y2 is 0. Sim- Similarly, we have M3, which is 3M, and then we have this X3, which is A by 2, and then Y3, which is A. So we can calculate the coordinate of center of mass, right? So x cm would be, this would be how much? M1 x1 plus M2 x2 plus M3 x3 divided by M1 plus M2 plus M. Right? So M1 is M, x1 is 0, then M2 is 2M, and x2 is A, and then M3 is 3M, and X3 is A by 2 divided by M plus 2M plus 3M. This is how much? This part cancels out. This is 2AM plus 3AM by 2 divided by 6M. Right? So this would be how much? This is 4 plus 3. 7 am divided by 2 into 6. So mm will cancel and this would be 7a by 12, right? And similarly, what would be the y coordinate of center of mass? So this would be m1 y1 plus m2 y2 plus m3 y3. And then this is m1 plus m2 plus so m1 is m into y1 was I guess 0, and y2 was again 0, and then y3 was 8. And then we have 6m. So this part cancels out, and this is 3am by 6m. So this is a by, right? So you see, yeah. So you see that where will this center of mass reside? So I can change this three particle system to a particle system whose coordinates are what? So whose coordinates are, let's say, a by 2 and 7a by 12. Right. So this is how much? This is 0.5, which is at this point, and 7a by 12 is how much? 0.6, I guess. So this is 0.5 and something like 0.5 and 0.6. This is a byte, right? And this is so somewhere around this point, right? This is a by 2 and this is 0. This is a by 2 and somewhere around here. So I can change this three particle system to a particle system, and then I can write the position vector, and then I can write its right. Is that clear?
Yes, sir. Yes, sir.
So what would be the position vector of this point?
It will be at
A by 2 I hat plus
plus
7a,
7 by 12 j.
right? So you see that I changed this three particle system to a one particle system, and now I can define all these motion of this particle, right? So that is how
Yes,
the center of mass is very important. Okay.
yes,
Yeah.
sir.
So did you understand this problem?
Yes, sir.
Okay, so please note it down from here. Yeah. So will all the masses of the body. Yeah, whenever you want me to scroll down, please.
Yes, sir. So can you scroll down?
This was the center of mass of this object. This kind of distributions. Only two particles, and those were lying on this x-axis.
So can you scroll down?
X CM, Y CM, and Z is. Yeah, whenever you have noticed down,
So can you scroll? So can you scroll down?
this is a particle, one particle, this is second particle, and this is the third particle. Yeah, whenever you have noticed down,
Yes, sir. I'm done, sir.
This part you also noted it down. Yes.
Yes, sir.
Okay, so now we can write the position of, so position vector of center. That would be how much? So that is R. And this is X CM I hat plus Y CM J hat plus Z CM the K hat. So this is the position vector of the uh, all these individual particles, right? So this is the position vector of the center of mass of the original particle, right? All the accumulation of those particles. Okay, so this was about the discrete system. But if we have a continuous system, so for the case of continuous system, so center of mass of continuous system. Right, so for the simple case, for the two-dimensional case, right, or for the three-dimensional or case also, so center of mass of continuous system which are regular, right, and which are irregular. So regular shapes are just like squares. We have this triangles. We have this what kind of? So then we have yeah. So something like squares and triangles, and then we have this circles. So for all these cases, the for all these geometrical shapes, so the center of mass of regular geometrical shapes will be the geometric center of all these geometries. Right. So if I talk about the square, and let's say this is regular, so masses are homogeneously distributed, right? So all the masses of these shapes are equal. Then the center of mass of this object would be the center of this object, right? Is that clear?
Yes, sir.
Yeah, and for the case of this equilateral triangle also, for the let's say the masses are same, then the center of this geometrical center, right? So the geometrical center of this object would be the center of mass. So these are for the regular shapes, right? But let's say if we have irregular and those are homogeneous kinds of distribution also. So for those things, we calculate the center of mass using the idea of integration, right? So for the case of the continuous system, the x center of mass would be integration of x dm. Okay, where this dm, so this dm is a very small mass distribution, right? So let's say you have, if you have this length of the rod and you are calculating the center of mass, then you define a very small patch of mass in this length, right? So you have defined this dm. So this and this dm is situated in this dx length. So for this dx length, this is the mass, right? And then what you do is that you integrate all these. So you define a position x where this dm mass is situated, and then let's say the length of this rod is from 0 to l. So then you integrate this thing, right? So this dm would be how much? So let's say this is a linear rod, right? So you have a linear mass density, right? And you assume that this is a homogeneous thing. So all these mass are homogeneously distributed. So patch of this mass is equal to patch of this mass. All these are homogeneous. Okay. So not like you have some this heavier mass in this part, some lighter mass in this part. So not unevenly distributed. The masses are evenly distributed, right? So these kind of masses are called homogeneous distribution. And for the case of homogeneous distribution, you define the mass density lambda as x or m by l, right? So this is the total mass, and then this is the length. So mass by length is linear mass density, right? And if I defined the surface mass density, so what would be that? Sigma would be how much? Yeah, if I have a square, and if I define this mass density sigma, right? So how much would this mass density be for the case of this area?
I uh, I don't know, sir. I don't understand that part.
Yeah, so density is something by length, volume, or area, right? So if I defined, let's say you define this density, mass density, how much is that? Mass density is mass by volume, right?
Yes,
If you're defining a volume, but let's say if you have an object which is linear in shape, so it doesn't contain the breadth and the height, then the density of this length would be mass divided by length. So this would be linear mass density, right? And then if you have this area, so then you will have this surface mass density. Okay, so this would be how much? Mass by area. And similarly, you have this volumetric mass density, right? Volumetric, then you will have this volume in the division. So is this part clear now?
yes,
Whatever,
sir.
yeah, whatever kinds of distance, different distribution you have. So let's say if we have a sheet, right? Then what kind of mass density this sheet will contain? Yes, for this sheet, what kind of mass density would be there?
Linear mass density.
So this sheet has this length and this breadth also, right?
Okay. Yes, sir.
So this will contain the surface mass density. Understood?
Yes, sir.
And let's say if I have a cube, right? And all these particles are distributed in this cube. So what kind of mass density would be there? Then I'll have volumetric mass density.
Yes, sir.
Right? So these kind of mass density that we have. So linear mass density is all the masses are distributed linearly. Okay, is that clear?
Yes, sir.
Yeah, so we'll do this question later, right? So this part we will do. So in the next class, I will solve the center of mass of a uniform rod. Uniform rod means that mass is evenly distributed, linear, right? So masses are linearly distributed. So this question we will do next class. So you have noted this part, up to this part you have noted it down, right?
Yes, sir.
So please note down this part and then this is regular and geometrical shapes, right? But the regular one with yes, whenever you have noted it down now.
And then, sir, can you scroll down? So can you scroll down?
This part, right? And this is also a regular shape, right? This is not an irregular. This is also a regular shape and uniform one, but this is not a geometrical shape, right? So we cannot find the geometrical centers. So whenever you have noted all these things,
Sir, can you scroll down?
yes, so this part we do what, right? Center of mass of a uniform. This question. Okay.
Yes, sir. And
So yeah, bye Rishita, and tomorrow we'll